Hello and welcome to another video. In this video we're going to be doing reveal cards in increasing order. And this is kind of similar to other problems we did, except it's going to be a little bit tougher. So you're given an integer array deck, and there's a deck of cards where every card has a unique integer. And the integer on the ith card is called deck I. And you can order the deck in any order you want. All the cards start face down. So you do the following steps. Take the top card of the deck, reveal it and take it out. And then take the next card and put it on the bottom. And if there's unrevealed cards, go back to step 1, otherwise stop. Return ordering the deck, that would reveal the cards in increasing order. Note that the first entry to the answer is considered the top of the deck. So what would happen here essentially is this is the order that you want. So they give you a deck in some order, which doesn't really matter at all, and they kind of tell you, because you can just reorder to whatever you want. So in this order, what would happen, I guess we can even walk through this example just to show it a lot clearer. So let's make an array like this. Technically, we don't even need indices really. We can just make a normal array. So let's just do it this way. Okay. So if we have this order, so 2, 13, 3, 11, 5, 17, 7. So essentially what you want is, like, when you do these operations, you want the numbers to come out in complete order. So what would happen is, in here, you take the first number out. So that first number will go over here. Then the second number goes to the back. Then you take the next number out. So put that over here. Then the second number, or the next top number, goes to the back, and you just keep doing this. So this number comes out. This number goes to the back. This number comes out. This number goes to the back. This number comes out. Then 17 goes to the back. Then we take out 13. And then 17 is last. So if we do this with this sorted, or with this kind of like array, then we get all our numbers in order. But if you try it in some other order, you won't get this. So essentially they're asking, like, get an ordering of the array that such that when you do these operations, take the first number out, then move the next one to the back, and so on. You get this. And that's the order you want here. And then for 1000, that one's pretty easy, because you would just take out one, put 1000 in the back, then take out 1000. So that's fine. So it's kind of easy to see a little bit of a pattern here, right? Like in the beginning, you notice, like, okay, well, I will take out every other thing. So I want, like, my first number to be here, my second number to be 2 away, and then 2 away, and then 2 away. But then it gets kind of tricky, like, what do I do with other numbers that are in between those? And it's kind of hard to find a pattern. Like, that's what I tried to do for like 10 minutes, just find a pattern that I could be like, oh, okay, I could see this pattern. Here's how you put everything in. And I wasn't able to do that. So instead, what we're going to do is we are going to sort our deck, and we're just going to simulate this exact thing with indices. So we can simulate this indices, and then we can know, like, okay, when we simulate this with indices, we'll just know, like, okay, what index got taken out first? That's where the first number should go. What index got taken out second? That's where the second number should go, and so on and so on. And so let's actually do that. So let's make a deck here. We can get rid of, like, all this other stuff. So we're going to make a deck in sorted order. So this will be all of our sorted numbers. And then we're going to have a queue of just indices, and then we'll have a result. So in sorted order, it's 2, 3, 5, 7, 11, 13, 17. So we're going to have this. And then we're also going to have just indices. So we're going to take this exact thing, copy it, and then just get rid of these numbers and put the indices in. And then we're just going to simulate this with the indices, and then we know exactly where these numbers need to go, and I'll show you how to do that. So this will be our simulation of the indices. We're going to run through this exact simulation that we did before. And then we're also going to have a result array. So we'll have a result array like this, and these will be up here that we actually are going to be returning. So we have a sorted array, right? Now this is going to be, so let's label all these things. So this is going to be like our sorted array. This will be our queue that we're simulating. And then this will be our result array that, like, we want to give back. So essentially what's going to happen here is we know that, okay, index 0 needs to have the first number, right? Because that's the first one that gets taken out. So we have this queue. So we take the first element, and then we just take it out, and we look, what index is it? So it's index 0. So that means the current element we're on in our sorted array, which is the first item, needs to be at index 0. right? So we can say, okay, the element we're on is 2, and this is at index 0, so we'll just put it in index 0. Now this is completely gone because this is like the card that's removed. Now the next card goes to the end. So we can just take, like, this is going to be the indices of where these are. And then we are going to take the next card out, right? So if we take this out, okay, well, what index is that? This is index 2. And so we already put in the 2, now we need to put in the 3. So that means that the 3 needs to go at index 2. And then this index goes to the back. Then this is over here. Then the next number that gets taken out needs to be at index 4. So that's a 5. Then we go to our next number. This gets taken out, and then let's move this. So here's our Q. So then the next one goes to the back, right? You take one out, you put it in the back. And you just keep doing this until you fill this whole thing out. So let's keep going. So the next number that gets taken out is index 6. And the number that needs to be there is the 8, because that's the next like current number from increasing size. Then this goes to the back. Then the next number that gets taken out is at index 3. And that number is 11. So there should be an 11 here. Then this goes to the back. And then the next number that gets taken out is index 1. That should be 13. And then 5 goes to the back, and then we just take out 5. So 17. So essentially, we come to the same conclusion as here, but we basically just have a queue of indices 0 through 6, or whatever the length of our array is, and we just figure out, like, okay, where does the first number need to be? So instead of using the actual numbers, we just use these as indices, right? So we start out with indices 0 through 6, and we just figure out, like, okay, if the first number is at index 0, then we better put the first number at index 0. If the second number is at index whatever, we put it there, and that's basically what we need. So we're going to have a queue, a sorted array, and a result, and that's pretty much it. There might be other ways to do this, but this is the way that I found was most intuitive. So this is the way we're going to do it. So let's code this in Java. And I believe in Java, there's a linked list queue and an array deck queue. And I actually had an interview problem from Microsoft for like implementing a queue with something like that, where you couldn't choose like push and pop and stuff. And I ended up making an array deck queue, but linked list is much easier. But let's just go with an array deck. Okay, so we need to sort the deck first, so we'll sort it. Then we need to make our, I guess we can get like the length of the deck, so call it like D or something, is the length. So essentially we want to make a queue with all items 0 to the length of the deck, kind of like in this picture here. So we want it to start out with like 0 through 6 and so on, so we can do that. And we'll just use like an array deck, I guess. So we'll say deck integer q equals new array deck. Yeah, and this should be integer. Or actually, I'm gonna do like this. Okay, so essentially, you can probably make it with a constructor. But I'm just gonna loop through and add in all these numbers. So we need to put in like 0 through the length of this thing. So we can say this, and then this is this. So we're gonna put in all these numbers into the queue. Yeah. So we'll say queue, and then it's kind of weird. So add adds to the back, and I think push adds to the front, which is kind of weird because push in most languages adds to the back. So I think we need to use add. So this should just be I. So essentially, if we have our queue, it'll add like 0, then 1, then 2, and so on. So yeah. Then we need to make a result array. So, and then this needs to be the same length as our deck. So this can just be new int array with size D. Then what we need to do is we need to simulate this whole like queue thing. So we can say like, while the queue has items, let's pop from the front, figure out what index that is, and then put our next item in there. So that's the other thing we need, is we need an index that start at 0, because we need to figure out like what element we're inserting, right? So we want like the first element to be at the first index that's popped, and so on and so on. So we can just say while queue size, we can pop an element off the front. So we can say int cur something equals queue, and then to pop from the front, I believe it's either pull it's either pull first or remove first. I think one link throws an exception, one doesn't. So we'll just use pull first. And then we need to, oh yeah, we can't do this. This isn't like truthy, so you actually have to do this, I believe. So we pull first, then we just, that's the item that will be, that's the next card from our deck that's removed. So we just need to figure out where that is, what index that is, and put that in the result. So we can say result at index cur needs to equal the current like number we're on. So this is just going to be deck at index I, and we can increment it. Okay, and then we need to now get the next thing and put it in the back. But sometimes we won't have more than one item. Like let's say our queue just has like this. We're going to pop this off. It'll be empty. So we need to check again if it's empty. So while queue size is greater than 0. You could like do this another way. You could like alternate in a while loop with some variable, but this is fine too. So if this is true, then we need to get this pull first and put it in the back. So we can say queue add this thing. So we take the first item, because like the first thing we pop off and we keep, and then the next thing we pop off and we just add to the end. And that should be it. So let's see what happens. Hopefully. Okay, yeah. Yeah, so there might be a better way to do this, but like I said, I was trying to find like a pattern for it and I couldn't. There might be something, like I just didn't want to take too long, but simulating indices is pretty straightforward. Just simulate which indices get popped off in which order, and then just put your items there. And so let's go through time space. So nlog n for sort. I think you have to sort. You can't really, there's not much of a way around that, but there might be some constant time solution or constant space solution. But in this case, it's O of n because we have a queue. And yeah, so definitely harder than the easy problem, but kind of same idea. Have a queue, simulate. This time we actually have to simulate. Before we didn't have to simulate, we could just get an answer. But this time we do, I think. Yeah, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.